Welcome to the Learning Pines YouTube. We hope this video helps.
You start by confirming what you have. Sodium or potassium salts dissolve differently, so measure concentration now. First, weigh the sample or check the label and dissolve to a known volume, record mg/L. Once done, measure pH and conductivity because those affect ion activity and perception. Make sure to note temperature, since solubility and sensor response change with degrees Celsius. Finally, prepare 2 identical glass samples labeled clearly, so you can compare sodium versus potassium effects under the same conditions. Now you run parallel tests to see how sodium versus potassium behave. Begin with physicochemical measurements, osmolarity, conductivity, and ionic strength. Record differences because sodium often yields higher conductivity per mg. Next, perform controlled taste trials with rinsing and randomized order. Use neutral volunteers and small sips. As you proceed, document sensations: saltiness, bitterness, metallic notes. Also, measure how each ion affects pH and buffering, since that explains some sensory differences and influences downstream biological responses. To finish, synthesize results. If the aim is reduced sodium intake and electrolyte balance, potassium often is better. If conductivity or stability matters, sodium can dominate. Adjust concentrations in controlled 10–20% increments until taste and chemistry targets align. Make sure to consider dietary limits and regulatory thresholds. If something goes wrong, strange conductivity or inconsistent tastes, recalibrate your meters. Verify sample labeling and repeat a blinded test. Small contamination or measurement drift.
Thanks for watching. Consider subscribing if we helped you.